In this tutorial, I'm going to explain how to create a 2D platform in Unity 3D and also using a Playmaker without any programming whatsoever. Well, Unity 3D is actually a game engine. It's really powerful. It has a lot of community uh, discussion forums and stuff, and it can also be used for exporting to Android, to iOS, even PlayStation and Nintendo and Xbox and stuff. And the best thing is it's free. It has pro version, but with the free version you can create a really cool game. We will also use Playmaker in this tutorial. Playmaker is basically a visual script editor. With it you can create games with no programming at all, just using functional state machine like the picture shown. I really recommend that you buy this plugins, this add-ons, and we will also use this free model from Asset Store. It is called Fightbot Free because it already has animation to use it in this tutorial. Okay, we'll start the tutorials. After we set a new project and create a new scene, we will need to import or download the Fightbot Free model and also the Playmaker into our project. First, we'll create a cube. This will be used as the ground, and we'll position the cube at 0.0.0. We'll stretch the x-axis to 12 units, keep the y value, and stretch the z-axis to 1.5 unit. And we will also position the camera for the z-axis to -7 and 1 for the y-axis. Next, we will create directional light for the scene and move it a bit upwards, and then we'll activate shadows using hard shadows. After we set the scene, next we will have to put the robot in the middle, and we will make sure to set the X position at 0 and also the Z position at 0. And before we meddle with the robot, we will have to first create an empty game object and then change the game object name to robot holder. Also put it at 0 and the z-axis at 0 and the y-axis 0.5, just like the position of the robot. And we will parent the robot object onto that robot holder. We will begin the fun part, but before we do that, we will need to add rigid body component under physics and also add capsule collider. We will have to adjust the capsule collider gizmo so it fits our character. Just fiddle with the parameter until you get the best size and shapes that represent our character. Next, we will add an FSM to the robot holder by going to Playmaker editor window and click Add FSM to robot holder. Before we go further with the FSM, we have to create variables first, and we will create a global variables so it can be checked with other FSM throughout the scene. We also need this to define the animation. Create a variable called horizontal axis and choose float for the type. Name that state and FSM to movement. And then we will add an action called get access. By typing the name on the search pane inside action browser, after get access is added to the movement state, change its axis name to horizontal, and then we will change its multiplier to 2.5, and we will store the axis into that global variables that we created before called horizontal axis. After we set that, we add another action into the same state, and the action is called set velocity. We will get the value from horizontal axis variable and feed it to the x velocity. Make sure the space param set to world and also check every frame. So as long we are inside that state, that action will be executed every frame. This is usually called a loop in programming. One more thing, make sure we check z-axis for freeze position parameter, and also make sure the x and z axis are checked for the freeze rotation parameter inside rigid body in the inspector pane. Now we will test that. Okay, sorry, I forgot to disable the script that came with the robot object. Just disable it by unchecking the checkbox beside the robot animation check script, and this will disable the interface. Let's try it again, and it works. Next, we will add action so the robot will turn depending his movement. For this kind of behavior, we can use the action called smooth look at direction. But this action needs factor 3 type object to calculate a game object direction. So we will create a new variable called direction, and we will set the type to factor 3, and we don't need this variable to be global. Local will be fine because this variable will not be shared to other FSM. We will set target direction parameter to get from that variable. Before we try this, we will need to add set factor 3 xyz above smooth look at direction. So it will be executed before smooth look at direction. We will need to put direction variable to the factor 3 variable param. And then for x-axis parameter, we will get value from variable horizontal axis. Make sure every frame is checked. We'll save the scene first. Okay, it is working, but it is facing the wrong direction somehow, so we will fix this in a jiff. We will need to change the y-axis of the robot holder to 90 degrees and the robot object y-axis to also 90 degrees. This way the character will turn according to the movement. Next, we will add another FSM to robot holder, and this FSM is just to handle jumping event. Just minimize the first FSM in the inspector and change the second one name to jumping event. On the first state, we will change the name to on ground. Then we will add get button down action to that state. and type jump to the button name parameter. We will also add a new transition event called jump press, and then under get button down we will send the event to jump press transition. But as you can see, Playmaker throw an error because we haven't added the jump transition to that state. Just right click on ground state and add the transition event called jump rest, and then we will add a new state and we will call it do jump. In the state we will add an add force action, and we will also set a value into the y-axis parameter. Just set it to 250. Make sure every frame is unchecked, and then connect the transition event jump press to do jump state. On do jump state we will add finish transition event and then connect the transition back to on ground. Let's try it. Okay, and it works, but there is problem because it can keep jump multiple times on the air, and it will be like a cheat in a game. So if we don't want that kind of behavior on our character, we will have to add a restriction on jump event. To check if the robot are either on the ground or if it's jumping, we will need add another cube as the trigger. Put it exactly as where the robot is and scale it down. We will change the other cube name to ground and hide it. So we can see the trigger as we adjusting its position and scale. And then we will remove mesh render component from the trigger, so the cube will only be acting as a ground detector and it will not be rendered in the gameplay. And in the box collider, make sure its trigger is checked, so we can use trigger event to detect whether the robot is on the ground or not. We will change the name to robot ground detect. After that, we will parent it to robot holder. Add an FSM to robot ground detect, and we will change the name of the first state to hit something. Add trigger event to hit something state. When this trigger collide with other object that has ground as a tag, send event will be fired, but we need to create the event first. Create a new event called hit ground and check the checkbox beside that event to turn it into a global event. We will unhide the ground and change the tag into ground tag. But this is not a default tag, so you can add a new tag by click add new tag and type ground. Go back to robot ground detect and add a transition hit ground to the state hit something, and then we will add a new state. This state will send an event to robot holder, jumping FSM, when it collides with other object. Connect hit ground to the second state, and then add send event action to that second state. On send event action, we will change the event target to game object FSM, and we will also change the game object to specify game object, and then drag the robot holder under hierarchy to game object slot inside send event. Choose jumping event in FSM, and we will send an event, and we don't need to create another event because hit ground event is already a global event. So we can go back to robot holder, and on jumping event FSM, add another state to listening if there is an event received from other FSM. Give it landing listener to the state name, and then add transition. Choose hit ground under global event. Connect the finish transition on do jump state to landing listener, and then connect hit ground back to the on ground state. This way we will only be able to jump again after we landed onto the ground first. And if we are still on landing listener state, we cannot press jump as it isn't defined in it. Go back to robot ground detect. On the send event action that resides on the second state, make sure hit ground selected under send event. Add transition finish to the state, and then connect it back to hit something. We'll save it again just to be on the safe side. Let's try it again. Let's see if it's possible to press jump while the robot is in the air. And now it is working correctly. Next, we will define the animation behavior so it will play animation according to its movement. If there is no movement, then idle animation is played. Otherwise, when running, then the running animation will be played, and also jump animation will be played if the robot is jumping. We will need to add an FSM to the robot object. We will add another global variable, and we choose boolean or bool as the variable type, and we'll name it is jumping. We will also name the FSM to animation, and then we will change the first state name to idle anim, add other state and name it to jump anim, also another one for run anim. Then we will add three different events in this FSM, and we will call the first one to idling, the second one to jumping, and the third one to running. Then we will add those transitions to each of the animation state. For idle anim, there is no need to add idling transition, so we will only add jumping and running as the transition. And for jumping, we will only add running transition, and for running, we will add both idling and jumping transition. We will change the transition order in run anim state, and then connect idle anim jumping transition to jump anim state, and running to run anim, and on run anim we'll connect jumping transition to jump anim state, and connect idling under run anim back to idle anim, and for running under jump anim we will connect it to run anim, so we create some sort of loop that will always check the robot current status. On idle anim, we will add boolean test action to check a boolean state. We will choose global variable is jumping as the boolean, and if it's true, send to jumping, then check every frame. After that, we will add another action called float compare to check our horizontal axis variable value. We will specify a variable on the first float by clicking use variables and then choose horizontal axis under global. With this action, there are three possibilities, either if the values are equal, less, or greater. And we will send running when the values are either less or greater, because if horizontal axis is not equal 0, then it means our robot is moving. So we will want the running animation played if it's the case. Make sure every frame is checked. To speed up things, I'll select these two actions and then paste it under run anim. For the float compare, we will reset less and greater event to none, and then we will set the equal event to idling. And for boolean test, we don't need to change anything. And on jump anim, we will add another bool test for the variable is jumping, but we will do nothing when it's true, but send to running when it's false. Let's see if it's working properly. Okay, when the robot's not moving, idle anim is active, and we can see it on the editor. Let's try moving, and voila, the state changed to run anim. Let's try jumping, and as we can see it, nothing happens. So we need to change or to set the is jumping variable first back on our robot handler jumping event. So when on ground state is active, we have to set the boolean value of is jumping to be false. So we will add set bool value onto it, and then choose is jumping variable, and we will not check the bool value, so it will be set to false. We don't need to check it every frame, so we will leave it as is. We will copy that action and then we'll paste it onto do jump state, but this time we will check the boolean value, so it will return the value true if the character is jumping. If we trace the state while on ground, is jumping will be false, but as we press jump button and do jump state activated, here is jumping will be set to true. Hence, it will toggles is jumping value back and forth accordingly. Now let's try again if the animation state are already working properly. Yep, it is. Already detect when the jump robot is jumping or not. All that left to do is adding play animation to each state and set animation accordingly. We will add play animation action into idle anim and then choose loop idle for anim name, and we will also copy the play animation action and then paste it to run anim and change the anim name to loop run funny. And for run anim, we will also need to add set animation speed action before play animation to change the run animation speed, because the animation that came with this robot is a bit slow. Well, this step is optional. We will choose loop run funny on anim name and change the speed value to 2.5. We will also paste the action again inside jump anim and change the anim name to jump. Let's save the scene just to be safe, and let's see if it's working. But before, I will hide the Playmaker Guy gizmo by simply disabling Playmaker Guy object in the inspector. So now it's working. When idling, the idle animation is playing, and when running, the running animation is played. And it is also the case with jumping, so we have covered all basic movement including animation. Lastly, we will need to add some sort of movement for the camera that will follow the character, so let's do that. Select the main camera and we will change the field of view to a value of 35, or better yet to 30. We will just type that, so the perspective will not be too distorted. And then add an FSM to that main camera and add smooth follow action to the first state. Drag robot holder to the target game object and we will set the distance to 7, the height to 1, and let the height damping at 2 and 0 on rotation damping. So there will be no rotation on the camera when the character rotates. It seems Playmaker create another Playmaker guy when we add a new FSM to the camera while Playmaker GUI inactive. So we will just delete the new one and then reactivate Playmaker GUI object but disable Playmaker GUI script in it. So it will prevent from creating a new GUI object, but it will also hide the debugging GUI in the game view. Just for fun, we will add another physics object. Simply create a cube and then scale it down a bit to 0 0.7 on every axis. Move it a bit upwards and then rotate it a bit on the Z axis. We will add a rigid body component to this cube and change its text to ground. Let's save it and try. Oops, there is a problem. Apparently, the cube is shifted a bit on the Z axis, so the robot does not collide with the cube at all. Let's fix this. Let's change the X position to 0 and also the Z position. In fact, let's slide the X position a bit and let's try it again. Okay, it's working, but looks like we'll need to constrain the cube just like what we do to the character. So let's do that. Check Z box under freeze position and under freeze rotation check X and Y box. Let's try it again. And it's working properly. We can push the box, go on top of it. With this, we can create an interesting 2.5D platform with physics interaction and nice 3D graphics. Perhaps something like Limbo. Thanks for watching. Hope this helps to get started with Playmaker.